Hello. We are going to be working on lesson 2.5. It's called Analyzing the Graph of Functions. And let's go ahead and get started. So if you printed out the notes, I have some of the problems listed there for you to look at. And the couple of first big points in this lesson is we have to decide if our function is an even function, an odd function, or neither. And if it's an even function, it means it's symmetric around the y-axis. So it's going to vertically look like it's flipping over left and right, symmetrical. So every f of x is equal to every f of negative x. An odd function is symmetric to the origin if f of negative x equals the negative of f of x. So it's symmetric to the origin. Okay, so we're going to look at a couple in Desmos. We're going to do the check it out number 1 on page 147. And they're listed out right here in the notes. So I'm going to go to Desmos and we're going to look at this first function here. So y equals 2 times the absolute value here of x. And this one is definitely even. It's symmetrical because you can tell, remember how if we go up here and make a table, we can see that -2 produces 4 and 2 produces 4. -1 produces 2 and 1 produces 2. So the note we can make is yes, the function above is even. Now let's look at the next function. Y equals, and then we have x plus 1, oops, x plus 1 squared. And I'm going to turn off my other function. This one, it's symmetrical, but it's not even. And we can look at the table here because a -1 produces 1, but a +2, a -2 produces 1, but a +2 produces 9. So they have to produce the same output. And it's not odd because the rule for the odd is that if you put in a -2, you would get a 1. And then if you put in a +2, you would get a -1. And that doesn't work either. So the function, oops, I got to turn that into a note. The function above is neither odd nor even. Okay. We're also going to talk about increasing and decreasing functions. And the definition is in our book here. And so let's turn to page 147 in the book. And it says a function is increasing on an open interval I if for any a and b where a is less than b, then the function of a also has to be less than the function of b, or the output of a has to be less than the output of b. It's decreasing if a is less than b and your function of a is greater than the function of b. And then it's constant if their outputs are equal. Okay, so we are going to look at page 148 to check it out. here. And it says, find the intervals where f is decreasing. So we can see that f is visually decreasing here to here. So between x -2 and x of 1, and then also from here to here, when x is 2 to x is 5. So let's just write that down. It's decreasing on the interval -2 to 1. And then we're going to union, remember that's a union, that with the interval of 2 to 5. And always remember when you're reporting your intervals, it's always the x values. It's never the y values. It's always the x values that you're letting me know. And then there's also times when we might want to see where do we have an increasing function or a constant function. We're going to do a couple here in a minute. And let's look at the average rate of change. So the average rate of change is taking the difference of the output, so the function x2 minus the function of x1, so the difference of their outputs divided by the difference in their inputs. It says, let's look at the check it out. We have the function of 2x squared plus 1 on this interval 3 to 4, and we want to find the average rate of change. So we need to find the function at 4, which we're going to put 4 in, and we'll get 2 times 16 plus 1, so 33. And then we also need to know the function at 3. So 2 times 9 plus 1 is 19. So the average rate of change, the arc, is the function of x2, which is 33, minus the function of x1, which is 19, divided by x2, which is 4 minus x3. So 33 minus 19 is 14 over 1. So the average rate of change of this function on this interval of 3 to 4 is 14. So this average rate of change is very similar to our slope, but this is not a linear equation. We have to remember that because we have a 2 on our exponent. Remember, a linear equation only has a 1 on our exponent. So, but this is the amount it's changing on this interval between 3 and 4. So let's look at page 152. Questions 14 through 18. And we're going to be using this picture here to answer these questions, this graph. So number 14 says, find the interval on which f is increasing. Interval or intervals. So we can see one here where it's going up. And remember, it's because everything's moving left to right. So there's one here where it's increasing. So 14 is going to have an interval between -4 and -3. It's increasing. And we're going to union that with, it looks like there's another one here from -2 to 2. And we're going to union that because it looks like there's another one here from 4 to 5. Then question 15 says, find the interval or intervals of which f is decreasing. So decreasing, we have here, it's decreasing from x is -3 to -2. We have another That looks like it's staying the same. We have another decreasing here from 3 to 4. Those look like are only 2 decreasing. 16 says find the interval or intervals on which f is constant. So where is it staying the same? And it looks like there's just one interval where it's staying the same, and that's between 2 and 3. This is constant. And then number 17 says find the y-intercept. So the y-intercept, where are we crossing the y-axis? It's when x equals 0. So let's find that here. So 0 and 1. Here's our y-intercept, 0 and 1. And then 18 says, find the average rate of change of f on the interval of -3 to -2. -3 to -2. Okay, so we need f of a -3 and f of a -2. So f of a -3 is at 4. And f of a -2 is at 0. So the average rate of change from -3 to -4, it looks like it's a decreasing pattern. So this should be a negative average rate of change. So this average rate of change should be 4 minus 0. And then we're going to say a -3 subtracting a -2. Because remember, it's got to be x2 minus x1. So we have 4 over a -1. So a -4 is our average rate of change on that interval between a -3 and a -2. You're going to get to experience some of these in your homework as well. Okay. I also want to look at some more on whether they're odd or even or neither. And we're going to look at, if you can go to your book, 27, 37, and 38. And good, it's focusing there. 27, 37, and 38. It's asking us if they're odd, even, or neither using the definitions. Okay, using the definitions. So using the definitions mean if I put in 1, I get 4. And if I put in a -1, I get 2. So for them to be even, these would have to equal. So if you go back to page 145, they would have to be equal. So not even. Okay. And then for odd, f of negative, the f of the negative x equals 2, we said, right? -1 would have to equal the negative. So the negative of f of x. So the negative of 1 then. And f of 1 is 4. So those would have to equal. And -4 and 2 do not equal. So it's not odd. So this one is neither. And we can see that by going to Desmos. So if we put in y equals x plus 3, you can see that it's not reflective over the origin. It would have to go through 0, 0 for that to be true. So let's just put in the next one into Desmos, and then we'll also look at it using our table. So we have y equals x squared plus 1. Oh, no, minus 3 times x squared plus 4 minus 4. Okay, and this is definitely an even, it looks like, and we can see that also by going and creating the table, because -2 produces 0 and a +2 produces 0, a -1 produces 6 and a 1 produces 6. So it qualifies as an even. Oops. So that one is even. And then number 38 and so let's put that one in. Y equals, oh, that was number 38. Oh, shoot. The one up above was 38. I better. And this one down here, we need to do is 37. I copied the wrong one. Sorry about that. So this one right here is 38. So I was talking correctly last time. It's just I looked down and did the wrong one. So this is x squared plus 1. And then we have x minus 1. I'm going to turn off this one up here. Okay. And this one, again, it looks like it could be odd, but it's not going to be because it's not centered at the origin. And we can see that in the table, and it's definitely not symmetric around the y-axis. So let's just go ahead and make the table here. So a -2 produces a -15, so that means 2 would have to produce +15, and it doesn't. So they're not opposite signs of each other. So this one, number 37 below, is neither. Or even. Okay. The next one I would like to look at with you is number 63 in your book. Okay, so I'm going to take you and show you on the page here. And we'll look at it together. From here, 63 says depreciation is going to be the content of what we're working on. The value of a computer 2 years after purchase is given by this function. The function equals 2000 minus 300t, where v of t is in dollars. So the value is in dollars. Find the average rate of change of the value of the computer on the interval between 0 and 3 and interpret it, explaining why the average rate of change of v on any interval will be the same. Okay. So let's look at this in Desmos. Oops. So we are going to this is number 60. Oh, no, that's not where I wanted to do that. Here. Okay, so we have y equals 2000 minus 300x. I'm going to turn off this other graph here. And it looks very straight. So you know what I'm going to do is I'm going to create the table. And then I'm going to go over here. Do you see where in the function at the bottom left, I'm going to hit the magnifying glass. So it just redoes our scaling for us so we can actually see it better on the graph. Okay, so now we can see our x-intercept, our y-intercept and our x-intercept right there. Okay. And it says, again, find the average rate of change of the value of the computer between the interval 0 to 3. So we need to do that. We need f of 3. We need f of 3. Oh, geez. I'm in the wrong spot here. So f of 3, we can go to our table and just put 3, and it will give us that output. So that is 1100. I'm just documenting here. And then because the interval, they want us to look at a 0 and 3, we also need f of 0. And that's already there in our table at 2000. So our average rate of change is going to be 1100 minus 2000 divided by 3 minus 0. Because the 3 has to go with 1100 and the 0 goes with 1000 as the x2 and x1 values up here. So our average rate of change is a negative 300. And then it says, why does this have to be the same on every interval that we look at? And that is because we have a linear equation here. And a linear equation has a constant rate of change. It's always the same between every interval. I'm just going to make that note for us. And that right there. Our note is we will have the same average rate of change between every interval because we have a linear function, and that by definition is a constant rate of change. So that's pretty cool. So catch me back for lesson 2.6.